Okay, so sorry about that. For some reason, my the rest of my last example didn't record. So, all right. So last example here, I wanted to do an example of a problem that had a vertical shift and a reflection. So those last two examples, if you remember, they had stretches and reflections. This one has a reflection and a shift. So something a little bit different that we didn't talk about here. So for our purposes, when we do these problems, we're always going to reflect and then we're going to shift. Okay, so we're going to reflect first and then we're going to shift at the end. Okay, now I don't want to put a blanket statement and saying every single time you see a negative, it's always going to be a reflection first. Okay, and a counterexample would be if it was like negative cosine of x plus 1. Then this, you would shift it up one and then you would reflect the whole thing. Okay. Or if this was a reflection over the x-axis, we're going to reflect it first when they look like this. This would be a reflection over the y-axis, then a shift to the left one. But it's going to be different. Let's say if all this was distributed, then we're changing the game a little bit here. Okay. So for our purposes, I'm not going to try to be sneaky or anything. You're going to see them written as this top one up here and this version right here, where everything's already factored out for us, and we don't have to worry about anything too crazy here. Okay, so for our purposes, we're going to reflect and then we're going to shift it. Okay, so for this one, we're just going to graph plain old cosine, and then we're going to reflect it over the x-axis and then just move it up one. Okay, so I'm going to try to skip a step here. So cosine of x has x-intercepts at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2. And usually, right, if you think about it, it's going to start by going up and has a maximum at 1. So if I reflect this over the x-axis, now it's just going to be down here with a minimum at negative 1. And then it's just going to kind of follow these x-intercepts. Okay, so this is the graph negative cosine of x. And then all I have to do is just move everything up one here. Okay, so I'm going to take all these maximums. Now they're going to be at 2. All these x-intercepts were at 1. This minimum is at negative 1. Now it's going to be at 0. And I'm just going to take all these key points and just move them up one. Okay, I'm going to give it a dotted graph here. What happened here? Oh, I missed this dot here. That's what happened. Okay. And so this graph right here would be my final negative cosine of x plus 1. Okay. So really pretty straightforward there, right? A nice little reflection over the x-axis. Everything got moved up one. Now, I made those numbers nice and pretty so that we know what these x-intercepts are already. But remember, if the numbers weren't as nice, we could always set the original equation equal to 0 minus 1 divide by negative 1. So I get 1 equals cosine of x. Take the inverse cosine, and that's 0, 2 pi, 4 pi, so on and so forth. And if you look, that's exactly where they hit, right? 0, 2 pi. This next one down here, it would have been negative 2 pi. And so we could have gotten all those values that way as well. Okay? So if you do a nice job with your transformations, if you have a nice grid and all your tick marks kind of work out nicely, you don't necessarily have to set it equal to 0 every time, but that's the sure bet way to make sure that you have the right x-intercepts. Okay? All right. So good luck today. I am going to be back on Monday to be there with you guys and kind of tie up loose ends. So thanks for all your hard work this week,